While we're waiting for folks, I see that there's a question already in the Q&A. There will be certificate of attendance given out for the training. It's not immediate, so stay tuned, but you will receive the certificate. And as you all know, it's required that members of the development team have a certificate for enterprise green or LEED projects coming through HPD. While we're waiting for a few more folks to join, just a couple items of housekeeping, which is this presentation is being recorded. And if anybody has questions, we will be monitoring the chat. Unless, do we prefer questions in the Q&A?
Yeah, let's keep questions in the Q&A, but feel free to use the chat if you want to have a comment or want to chat with each other at all.
Great. And we'll cover all these other questions that are popping up throughout the course of the presentation, but the session will be offered next, I believe, in July. Jenny, is that right? I'm not looking at a calendar.
Yes, it will be offered next, I believe, in July.
Great. Well, it looks like we can go ahead and get started. I'm going to close this chat. So good morning, everybody. Happy Earth Month. Hope everyone had a really exciting Earth Week. Activities are still going on, including some of our own. My name's Jen Leone. I'm the Chief Sustainability Officer at HPD, Department of Housing, Preservation, and Development. And in our world at HPD, I think many of you who already know me know that we address all sorts of climate-related issues, sustainability and resiliency. And we primarily do that through enterprise green or LEED for our new construction and substantial rehab projects. But we also now have design guidelines that cover all of the work that we do at HPD. We recently released preservation design guidelines that cover our moderate rehabs and our substantial rehabs. This is a big deal. We've never had official design guidelines for any part of our preservation work. And this summer, we'll be releasing our updates to our new construction design guidelines. We've had new construction design guidelines for a while, but these will be some exciting updates related to decarbonization, electrification, and resiliency. So stay tuned. This presentation covers a lot of the work that we've been doing through Enterprise Green, but also talks to the kind of initiatives that are embedded in our upcoming design guideline updates. I don't have much else to say. We're really excited about this presentation. We've been working on it for a while with our friends at Building Energy Exchange, the New York City Accelerator, Stephen Winter Associates, and the Mayor's Office of Climate and Environmental Justice. I am going to turn it over to Leanne and Kelly, but I just want to say one thing, which is stay tuned for news. Earth Week's not over, and HPD has some pretty exciting announcements to come in the next week or so. So with that, I'm going to go off camera, and I will be monitoring the Q&A throughout the course of this presentation.
Hi, everyone. Thanks, Jen, for the intro. That was great. And I am Kelly Westby. I'm the Managing Director of the Building Operations Decarbonization and Efficiency team at Stephen Winter Associates. We're providing technical support for the New York City Accelerator program. And so I'm going to be presenting today along with my colleague who's also here, Leanne Harvey, a Senior Sustainability Consultant at SWA. We're here representing the Accelerator on this presentation. So we have a 3-hour presentation for you, course for you, and we'll focus on the integration of resiliency and high performance strategies into the building design. We want to provide you with the tools to achieve New York City's goals for energy efficiency and carbon emission reductions, mitigate current and prepare for future risks, climate risks, and generate efficient, safe, healthy, and of course, affordable housing. We do have a 3-hour presentation, but don't worry, we will break it up with questions and thoughts. Please feel free to type any comments and thoughts in the chat, as Leanne was mentioning, and questions in the question and answer, so we can make sure we get back to you on those. And if we don't have the answer right away, we will follow up. The session is being recorded, and we also just want to note that all of the poll questions will need to be answered in order for you to receive credit for this. So there'll be poll questions smattered throughout, so we can stay engaged and stay thinking about things, and those questions are required to be answered. And the session today is broken up into a couple of different parts. So we'll have the introduction, we'll give you some context, so just context around climate change in general and how it's impacting New York City. We'll talk about designing for a climate-ready building, which is climate-ready is a resilient building that's also high performance. Then we'll talk about implementing a climate-ready building using integrative design. And then we'll look at concepts and action through following a case study of beach green dunes. And then we'll wrap it up with some conclusions. We hope you will learn something over the course of this course. So upon completing this, we hope that you can summarize the critical policies and codes and standards advancing New York's climate change mitigation goals. We want you to better understand resilient and high performance design and identify key design strategies to apply, and then be able to apply those integrative design process, which is critical for successfully implementing a climate ready building. So we're going to start off with a softball. What is your profession? So you should have a poll pop up, and I get to see the answers. So we definitely have architects, engineers, owners and developers, consultants. We have a few others. If you are a other, maybe type your profession in the chat. Let us know who's out there. We've got some HPD staff. Excellent. That's great. So this, I'm so glad to see that we have architect, engineer, contractor, owner, consultant, HPD all represented on this call, because all of you are critical to developing a high performance and resilient building.
Great. Thanks, Kelly. So let's go ahead and dive in. A lot of what we're going to be talking about today will be kind of refresher content for many of you. But we really want to start with a solid foundation and build off of how climate change is impacting New York and how our buildings play an important role. So as you very likely well know, climate change is caused by greenhouse gases, or GHGs, which are released from burning fossil fuels such as coal, oil, and gas for energy. So higher concentrations of GHGs in the atmosphere result in a warmer planet, altered weather patterns, and more powerful storms. The Intergovernmental Panel on Climate Change, or the IPCC, is a group assembled by the UN to monitor and assess all global science related to climate change. So according to the IPCC's recent assessment reports, if global warming exceeds 1.5 degrees Celsius in the coming decades, we can expect more severe storms, flooding, heat waves, and shorter cold seasons. We also know from this report that immediate actions that limit global warming close to that 1.5 degrees would substantially reduce, but can't eliminate, projected losses and damages related to climate change. So because these impacts can't be fully eliminated, we have to be climate ready. So here in New York, we're already feeling the impacts of climate change. throughout the region as well. In 2021, it was the Northeast's third warmest year since 1895. And annual temperatures in New York have gone up about 2.4 degrees Fahrenheit since 1970 and are projected to continue to rise between 4 to 6 degrees by the 2080s. Higher temperatures also mean extreme heat and longer heat waves, which is a severe health risk. In 2080, New York City could experience up to 87 days above 90 degrees Fahrenheit and 6 heat waves per year. More Americans die from heat waves every year than from all other extreme weather events combined. So we wanted to ask you a question. What percentage of New York City heat stroke death occurred due to indoor heat stress in buildings in 2019? So Jenny, if you could launch the poll. So we're not expecting you to know this, but take a guess and we'll talk about it. All right, seeing some answers coming in. Let's get to 100% participation. We're getting there. All right. Inching up. So let's see, I'll just give you one more moment to answer for anyone that's struggling to get that poll question up. All right, so the correct answer is 71%. That is extremely high and really concerning. Folks die from heat stroke inside of their homes because they may be living in poorly weatherized homes. They don't have or can't afford air conditioning and may have chronic illnesses that force them to spend more time indoors during heat waves. So the increase in temperature also means more moisture in the air, leading to increased rain, snow, and storms. Overall, average annual precipitation has increased across New York State since 1900 and is expected to continue increasing with more frequent storm events and heavier downpours. 2019 was one of the US's wettest years on record. And by the 2050s, average annual precipitation may increase as much as 13%. According to the New York DEP, the Northeast experienced an over 70% increase in heavy precipitation from 1958 to 2010. That's greater than any other region in the country. These frequent and intense rain events lead to flooding, which can result in costly damages to homes, roads, bridges, and other important infrastructure. And a NYSERDA study estimated that property damage losses from flooding have cost over $7 billion from 1960 to 2014. We're also experiencing sea level rise. So per Flood Help New York, sea levels in New York City are rising nearly twice as fast as the global average. So let's do another pop quiz here. How much has sea level risen along New York's coast since 1900? All right, got some answers coming in. Give everyone a few more minutes here. Or moments, I should say. All right, it's looking like majority are getting this answer correct. All right, looks like it's steadying out now. So for those that answered 12 inches, you got this one right. So by 2080, we could see sea levels rise by nearly 7 feet. It's already risen 12 inches and is expected to continue to rise. And these rising sea levels lead to growing storm surges, increasing the flooding risk from rain and storm events. And since 2014, HPD has built or closed 371 projects, 60% of which are new construction within the 2080s floodplain, which again is why climate-ready design is so important for future projects. So to reduce current and future impacts of climate change, we must take immediate action. And as you can see from this chart here, buildings are the leading source of greenhouse gas emissions in New York City. And buildings are also a primary line of defense for those climate impacts to come. So how do we change our practices in building use and construction to reduce greenhouse gas emissions? Before we dive in, just want to make sure we've defined some clear terms. We're all on the same page. When we're talking about decarbonization, it simply means reducing greenhouse gas emissions, reducing that carbon from the atmosphere. Electrification involves replacing fossil fuel powered technologies with technologies that are powered by electricity. So when it comes to buildings, this means replacing furnaces and gas ranges with heat pumps and induction cooktops. And finally, beneficial electrification is used to ensure that electrification provides the most benefits and makes economic sense. You wouldn't want to swap out a gas boiler for an inefficient electric system that increases energy bills just for the sake of electrifying. So with that in mind, let's look at how New York is applying these strategies to the building sector to mitigate climate change. We'll talk through strategic policies, codes, and standards listed here, which impact the affordable housing sector. So let's start with the mayor's office. The mayor's office has played a key role in shaping the city's climate policy. In 2008, Mayor Bloomberg released a strategic plan entitled Plan NYC with a focus on growth, economy, climate change, and quality of life. Then building on that, Mayor de Blasio released One NYC in 2015, a strategic development plan focused on principles of growth, equity, sustainability, and resiliency. So key initiatives of this plan were to ensure that all New Yorkers have access to safe, secure, and affordable housing, achieve carbon neutrality and 100% clean electricity, and to strengthen communities, buildings, infrastructure, and the waterfront to be more resilient. And in 2023, Mayor Adams is expected to release a climate action plan, which will prioritize environmental justice. The city launched a program to provide technical assistance to building owners to take action towards reducing their building's carbon emissions. This is the accelerator, what's bringing us here today. The program has evolved over the years and today continues to offer free guidance to any privately owned new or existing building over 5,000 square feet. It's a great resource for navigating requirements and identifying financial incentives and financing. And we'll hear more about the accelerator at the end of today's presentation. So I'm sure many of you are familiar with the Climate Mobilization Act passed in 2019, aimed at curbing greenhouse gas emissions. This includes a suite of local laws, and we'll cover the laws that are most important for HPD-funded buildings. Starting with Local Law 92 and 94. This requires that all new buildings and any existing buildings doing roof work must install green roofs or solar PV. So HPD has a carve out in the policy, which excludes affordable housing projects until 2024. But to take advantage of incentives, HPD created their solar where feasible policy, requiring solar on affordable housing only when it's cost effective. So teams must submit a solar feasibility analysis to HPD and install solar where it's deemed financially feasible. And though each building and solar array is unique, HPD reports that a typical payback period is less than 10 years. The cornerstone of the CMA is Local Law 97, which establishes carbon emission limits in buildings over 25,000 square feet. So buildings are categorized based on their use type, and each category has its own carbon intensity limit. Limits are determined by multiplying the gross floor area by the carbon intensity coefficient associated with the occupancy. And emission limits become increasingly stringent over time and are subject to fines for noncompliance. Buildings that include affordable and regulated housing are not exempt from Local Law 97, but may be treated differently under key articles. So depending on key factors such as the number of dwelling units, as well as the rental or ownership structure, and affordable housing is subject to specific emission limit requirements and key deadlines. Most HPD projects are subject to Article 321, which requires covered buildings can prove by May 1st of 2025 that either they didn't exceed that carbon limit that was set through Local Law 97, or that they implemented applicable prescriptive energy conservation measures by December, the end of the year of 2024. So they kind of have two options there. This chart is super useful. HPD has a lot of really helpful flowcharts and information on the website that I recommend you check out. So Local Law 154 is another law targeting carbon emissions and effectively bans the use of gas in buildings in all new buildings and gut renovations. So this starts in 2024 with a phased rollout, starting with low-rise buildings, and then taller buildings are added in 2027. So again, it's a little bit different for affordable housing. Affordable housing projects are on an alternative timeline with delayed compliance deadlines. Buildings with 50% or more affordable housing will be given until 2026 to comply for the low rise, and then 2028 for taller buildings. One thing to note here is that electrification of building service, water heating systems are not mandatory in the first phase and have additional time to comply with this requirement. So moving on to the state level, the Community Leadership and Climate Protection Act, or the CLCPA of 2019, outlines a path for New York State to reach net zero greenhouse gas emissions. So this law requires the state add significant renewable energy and energy storage capacity to the grid. So specific targets include achieving 100% zero emissions electricity by 2040, and reducing emissions at least 85% below 1990 levels by 2050. So this is why electrification, and beneficial electrification specifically, makes sense. We're cleaning the grid. We have these other targets in mind. So it's, they have to happen in tandem. In addition to these policies and laws, energy codes are also getting more stringent. So two key codes are the New York City Energy Conservation Code and the New York City Stretch Code. So these are closely aligned on efficiency measures such as insulation, lighting standards, and future codes will continue to get stricter. Starting in 2025, the city's energy code for buildings will require a specific level of energy performance that's significantly more stringent than baseline code and moves us closer towards passive house performance levels. This is very significant as teams will have to utilize performance-based energy modeling rather than prescriptive measures to demonstrate compliance. So the policies we've been discussing are addressing how we use energy in buildings and using it more efficiently and moving away from non-renewable fossil fuels towards sustainable energy sources. The Climate Resiliency Design Guidelines and Local Law 41 of 2021 are focused on driving resilient design so that New York City's building stock can weather changing conditions, growing stresses, and extreme weather events. These guidelines translate future-looking climate change projections into technical guidance to ensure that capital projects constructed today will be prepared for worsening weather decades into the future. So there's a 5-year pilot program to apply the design guidelines on 35 capital projects, including 3 HPD projects. And by 2026, all city projects must meet a stringent set of requirements that will certify their preparedness for extreme weather threats. More and more developers are electing to design for resiliency, going beyond code and ensuring their buildings are ready to withstand climate change. And we'll look at those, especially in the case study later in this presentation. The Uniform Stormwater Rule and release of the New York City Stormwater Manual updates and aligns water quantity requirements in the city's combined sewer drainage areas with water quality requirements in separately sewer drainage areas, providing a comprehensive citywide stormwater management policy for public and private development. So the manual provides technical guidance for developers, designers, and engineers who work with DEP on stormwater permitting. It's required for projects that disturb 20,000 square feet of soil or create a 5,000 square foot of impervious surface. So next we'll dive into HPD policies and guidance for resilient and energy efficient affordable housing. So Enterprise Green Communities is a national green building standard. Again, I'm sure all of you are very familiar with Enterprise. The 2020 criteria has a certification plus for pursuing high performance certifications and a greater emphasis on health and wellness via an alignment with the well building standard. So, as you know, EGC is organized into specific categories such as integrative design, site improvement, and operating energy. Some criteria are mandatory while others are worth optional points. HPD projects must go beyond the national criteria and comply with the New York City overlay, which shapes EGC to address the city's unique needs and goals. So the New York City overlay requires projects to achieve more points for certification and makes certain criteria mandatory instead of optional. The new multifamily supportive housing and senior housing HPD funded projects must follow the HPD design guidelines for new construction, which establishes the criteria to evaluate proposed developments. As Jen mentioned, the 2021 guidelines are being updated this year to align with New York City and HPD's climate goals and will include all electric building requirements, new future-looking resiliency requirements, and new criteria for health and well-being. So we can expect to see those updates later in the year. And finally, to support beneficial electrification, HPD has developed policies for electric heating to protect residents and ensure performance. So the electric heating policy and tenant paid heat policy enables tenant paid heating in limited situations. It does require HPD permission. It restricts resident paid heat on projects with vulnerable residents like seniors or formerly homeless. It also specifies it only allows for high efficiency equipment. Again, we don't just want to replace equipment if it's not going to be highly efficient, if it's not going to help save money as well and save energy, and refers to new heat pump utility allowances. So our next question, let's see what you remember from that overview. How many days of over 90-degree temperatures are we likely to face by the 2080s? Right? Looks like about half of folks have participated. Let's get that number up. And it looks like most of you are getting this one correct as well, which is great. All right, starting to steady out. So good that lots of you have good recall here. As we stated before, it's 87 days of over 90 degrees, which is a lot. And one more question for you before we move on to our next section. Again, for that recall, how many feet of sea level rise might New York City face by the 2080s? This one's a little tricky because I rounded up when I was talking about it. But looks like most of you are getting this one correct as well. All right, looks like we're evening out with responses coming in. So for those that said 6.75, you got it right. All right. So now we're gonna dig into designing a climate ready building. Starting with resilient and high performance design. So as professionals and practitioners in the building industry, we need to design, construct, and operate buildings that mitigate and adapt to climate change, meet New York's current and future ambitious climate laws, and meet HPD's metrics for safe, healthy, and affordable housing. So how do we do that? By combining those resiliency and high performance strategies into affordable housing projects. So what is a high performance design and how is it different than business as usual? So high performance buildings reduce energy consumption and carbon emissions while ensuring the health and safety of occupants and the energy grid. So more specifically, they'll utilize highly efficient all electric equipment to minimize or eliminate reliance on fossil fuels and reduce peak loads. They're super airtight, minimizing heat exchange and maintaining comfortable and even temperatures. And they have balanced ventilation, providing fresh air and reducing the heating and cooling load through energy recovery. They're often designed to standards, which we'll dig into more later. Resilient buildings, how are these different than business as usual? So resilient buildings can withstand and recover from extreme heat, extreme storms, flooding, and more. They're future forward. They're using climate information to maximize impact and ensure the building continues to withstand and evolve to changing conditions. So resiliency and enterprise green communities, the New York City overlay under the 2020 criteria has additional resiliency focused requirements and opportunities to earn optional points. So resilient and high performance design strategies come together to create a climate ready building. So these buildings, they're healthier, safer, and more efficient. They lower greenhouse gas emissions, affordable, and future proof. So let's dig into some of the benefits. But first, I want to get a guess, roughly what % of energy use comes from heating a conventional building? Again, this is a rough guess, but want to see your thoughts on this one. If we could launch this poll. Jenny, can we get this poll up?
Sorry, yeah, I'm trying it. I'm just having a little technical difficulties. 1 second.
No worries.
There we go.
Great, thank you. All right. This is a close call between 30 to 40 and 50 to 55. Give it one more moment for folks to answer. All right, looks like we're evened out here in terms of responses coming in. So those that answered between 50 to 55 have this one right. Obviously, you know, this is a general look, but you know, comparing these two charts, climate ready buildings use significantly less energy than conventional buildings. So this chart here compares the end-use breakdown between a passive house building and a conventional building. And you'll notice that the passive house total energy consumption is cut by more than half compared to the conventional building, and that's mostly due to heating. It takes a lot to heat our buildings. Because climate ready buildings consume less energy than conventional buildings, they are also much less likely to be at risk from accelerating energy costs or spikes. So the green row in this table shows percentage energy cost savings for 6 case studies. You'll see that with a climate ready, high performance, resilient building, we see those costs go down. Climate ready buildings have significantly lower greenhouse gas emissions than conventional buildings. So SWA performed a study comparing 6 passive house buildings with conventional buildings, passive house in green, conventional in gray, and the greenhouse gas emissions from those passive house buildings are significantly lower than that 2030 limit that's set by Local Law 97 that we discussed earlier, while the conventional buildings are much higher. So this means that passive house buildings, you know, won't face those fines from Local Law 97, and you know, can also avoid future fines as those limits continue to go down, and it gets, you know, stricter over time. Climate ready buildings are healthier because they provide fresh filtered air, resulting in better indoor air quality. So this chart shows the results of an AIQ monitoring for several schools. The conventional buildings have higher CO2 spikes, while the passive house buildings maintain healthier levels. You'll see conventional in yellow, passive house down here. And we all know how uncomfortable a drafty window can be. I know in my apartment, it can get very cold. Climate ready buildings limit the amount of heat transfer, keeping the space conditioned to an appropriate temperature. This image here shows an infrared scan of a block, and this is a passive house building. It has almost zero heat transfer through the envelope. So here's our next question. Wondering, during a blackout, about how many days could one survive in a climate ready building? All right. Great. Looks like a lot of folks have answered this one correct as well. So yeah, absolutely. So Urban Green Council modeled indoor temperature changes during a blackout for different building types and performance levels, and found that in winter it takes 7 days for a building to become uninhabitable, while a conventional building only takes 2. So climate ready buildings are safer. They maintain those livable conditions even during periods of power outages. Finally, climate-ready buildings are future-proof. They're safer, have lower risk from climate impacts, resulting in the potential to save money. So this graphic shows that elevating your homes can lower insurance premiums. HPD has already developed some climate-ready buildings, all of which are Passive House certified. So the Knickerbocker Commons in Brooklyn, it was New York State's first 100% affordable multifamily Passive House building. 475 Grand Concourse, this is in the Bronx. It features green roof trays, setback roofs to reduce stormwater runoff, and a cistern to collect stormwater for irrigation. Mapes Ave, also in the Bronx, features an innovative solution for window ACs that allows them to be closed and thermally isolated during the heating season. And Sendero Verde has over 700 units of affordable housing. It is the largest fully affordable passive house building in the world, and it features triple pane windows assemblies consisting of thermally broken metal frames for the tower and highly insulative UPVC windows for 2 of the 3 buildings. So earlier we asked about the heating percentage in conventional buildings. Now, do you remember what that percentage was in the chart that we looked at for the passive house building? All right. Give folks just one more moment here. All right, this one was close, but for those that answered 5 to 10%, you have that correct. When we looked at that chart before, passive house buildings, the heating dropped down, from 50 to 55 to 5 to 10. So one last question before we move to our next section. We just want to hear from you. What's one attribute of a climate-ready building that stood out to you today? And as folks are, answering this one, do you have any questions? Feel free to comment in the chat. Yeah. All right, got nearing half participation. Let's see if we can get that up a little bit. All right. So feel free to continue answering. Oh, looks like the poll ended. But let us go ahead and move on to our next section. We'll be looking specifically at design strategies. So I'll pass it back to Kelly for this.
Excellent. Thanks, Leanne. So we are going to get into building on that previous section and get a little bit more into the details of the design. We'll speak to how the resilient and high performance design measures come together to create a climate ready building. In this section, we've kind of broken the climate ready building down into 8 parts. So we have, we have site, envelope, heating and cooling, ventilation, water, lighting and loads. You can see those together. Resilient and renewable systems, and materials. we'll start out with the site and go through in order. As we look through the measures, we'll talk about what our best practices are, and then we'll see how they relate to our EGC criteria. So we have specific design strategies that can greatly improve the resiliency of a building overall and the safety of its occupants, as well as neighboring communities. And this is especially important during extreme weather events. The location of your building directly influences its exposure to climate risks. So as an example, a project might be at greater risk for flooding if it's located close to a coastal waterway or in low-lying areas. We need to think about the design strategies and the site design as a key line of defense for these external stressors. We're going to look at 3 key design strategies: floodproofing, stormwater management, and heat island mitigation. We'll review how to assess your site's resiliency needs, and then we'll talk later in section 3 about the exposure screening tool. For now, I'm just going to give you an overview of those strategies. So starting with floodproofing. We want to elevate the residential uses, elevate those critical equipment such as HVAC equipment, elevate means of egress above the future design flood elevation DFE. Natural flood mitigation features like berms or living shorelines can provide added protection as well. We can protect using wet or dry floodproofing strategies like deployable flood barriers or temporary dam seal off points of infiltration. Teams need to account for not only the current but future flood elevations to help ensure that the building is prepared for extreme events in the future. For stormwater management, impermeable materials really exacerbate flooding as the water flows quickly and overloads into the sewer system. It's critical to design ways to control these high volumes of stormwater. We do this by reducing hardscape. Some of the options we can look at are, thinking about permeable paving. Having trouble with all the P's in this slide. Permeable paving allows stormwater to be naturally absorbed into the ground through porous hardscape materials. You can also consider bioswales or rain gardens, which are vegetated areas designed specifically to collect and manage stormwater. These design strategies are particularly relevant for New York City because of the combined sewer system, which manages both sanitary and stormwater flows. It's often at risk for overflow, which means that our dirty sewer water, like the water from your toilet, goes directly into the local waterways when it rains. Floodproofing and stormwater design strategies work in concert to protect the building from increased precipitation and tidal inundation. And lastly, in this section, we're looking at heat island mitigation. So since structures like buildings and roads absorb and then re-emit the sun's heat, more so than natural landscapes, urban areas often experience higher temperatures, which can be unsafe for residents and taxing on the building cooling systems as well. Green roofs with native or adaptive vegetation can help manage and reduce ambient temperatures at the roof. And then there's also co-benefits for those types of systems. You get reduced stormwater runoff, increased biodiversity, and it's also quite lovely of an amenity for occupants. So teams have to, for these types of systems, make sure that they account for the structural needs of the green roof early in design. And it's important that you use native or adaptive plants so that you reduce the water demand, since the native or adaptive plants will be suited for the New York City climate. We also want to consider reflective or reflective paving or roofing. Light colored, also known as high albedo materials, reflect light and don't absorb heat. Select materials with an appropriate solar reflectance based on where they're going to be located. So you can use ultra white materials if they're installed in uninhabitable roofs, but light colored materials with a lower solar reflectance are more suitable in amenity spaces, such as terraces, balconies, courtyards. so that residents aren't subjected to that harsh reflected light. You can also provide shading with trees or trellises or solar canopies, and these can provide an additional comfort for amenity spaces. These measures also reduce air conditioning demands needed to cool the building and maintain a comfortable living environment for occupants. Integrating green roofs into the building can help comply with local law 92 or 94 requirements that Leanne mentioned earlier, in particular in spaces where solar PV isn't feasible. Combining green roofs and solar, which we'll discuss a little more later, can actually enhance the performance of both systems, providing shade that helps the plants grow and lowering the ambient temperature, which increases the efficiency of solar panels. And the EGC criteria, we're going to skim through these slides, but we want you all to have a reference for where do these show up within the criteria, whether they're mandatory or optional, and also to see whether they apply to energy, resiliency, health, potentially all three in some cases. Next, we talk about the envelope. So a high performance building envelope can reduce energy use and infiltration, increase comfort, and keep occupants safe from the impacts of climate change. The building envelope helps control the transmission of heat, air, and moisture. A highly insulated and airtight envelope is fundamental to reducing the HVAC loads, improving overall comfort, and enabling occupants to shelter in place during and after natural disasters. A robust and airtight envelope can save energy and minimize operating costs based on reduced demand for heating and cooling. A high-performance envelope requires more oversight, such as progress inspections and performance testing, like blower door testing. These need to happen throughout construction to check for and correct any inconsistencies in the air or thermal barrier. We'll look at a couple of ways to do just that. So thinking about simple forms. Simple forms result in fewer mistakes and save cost as well. Complex geometries for a building enclosure can really create a lot of opportunities for thermal bridging and for air infiltration. Also, consider the building orientation for a more passive design. Also, really consider the optimal window to wall ratio. The window to wall ratio is the total fenestration or window area divided by the total wall area. Heat loss and gain through the windows is much greater than a typical wall construction. So it has a significant impact on the thermal comfort of the building occupants inside the space. Energy code has prescriptive maximum window to wall ratio, and the value depends on the pathway, New York City Energy Code or ASHRAE, whatever you're following, whether you're modeling or using prescriptive. Consider the facade orientation, the code and building standard requirements, and your project goals to make sure you have something appropriate for each project. Robust insulation with minimal penetrations is critical to the success of your project. So a robust envelope acts like a thermos, which keeps the indoor environment comfortable and consistent even as temperatures and conditions outside obviously fluctuate during the day and over the course of the year. Continuous insulation will help us maintain consistent temperatures by eliminating pathways for heat to travel in and out of the building. If we reduce the size and quantity of penetrations through the insulation as much as possible, and think about penetrations, things like balconies, parapets, equipment dunnage, facade attachments, such as signage and shading devices. You can see kind of in the image here, some thermal bridging happening. Thermal breaks, on the other hand, at penetrations, provide a barrier between the inside and the outside. So thermal bridging is like the handle on a metal pot. It acts like a conduit for heat transfer. For unavoidable penetrations, consider different strategies. You might have a thermal brake pad. Autoclaved aerated concrete is one solution. And other insulative structural components that can maintain the structural integrity of the assembly while minimizing energy transfer, like offset shelf angles. Conventional windows and doors often have poor thermal performance and also cause substantial air infiltration if not properly installed. These problems can be solved by installing high-performance windows and doors that are well insulated, thermally broken, and airtight. There's a couple of things to consider here. So the U factor indicates thermal transmittance, or how much heat is conducted. The lower the value, the better the window insulates. Look at the assembly U value, which includes the frame and the glazing. It's possible to have a high performance glazing, but poor framing that reduces the overall thermal performance of the window. While high performance windows may cost more than the standard windows, there will be significant energy savings. And you don't necessarily need triple pane to be high performance. So consider your options and the cost effectiveness. Solar heat gain, you need to make sure that you have a climate appropriate solar heat gain number. Solar heat gain measures the solar energy that passes through the glazing. The lower the SHGC, the less solar heat is transmitted and the greater shading ability. Recent energy codes include more stringent requirement for fenestration or windows, for the most part, which reduces the U factor and SHGC. Performance requirements for glazed assemblies, such as windows, doors, skylights, and will likely become more stringent with time over future codes. You need to work together with your team to understand the optimal U factor and SHGC values for glazed assemblies based on the facade orientation, code, and building standard requirements. These strategies may also include things like shading devices, recessed windows that can help with solar heat gain. So don't just stick to the window criteria. And thermally broken assemblies, similar to structural thermal breaks, thermally broken windows and doors include insulated barrier that helps minimize heat transfer through the frame. So next we get into air and water tightness. So gaps in the building envelope significantly affect energy performance and result in drafty, uncomfortable occupant spaces. Improving air tightness at points of infiltration, including windows, doors, mechanical and plumbing penetrations, saves energy and increases indoor air comfort. Teams must use an air barrier continuity plan to ensure there aren't any gaps in the air barrier materials, particularly at transitions. This can help identify problems early and even in design before they are happening, rather than just happening upon them during your construction process. We also need to do a good job thoroughly sealing during construction to prevent infiltration. Additional air sealing at any penetrations within the envelope around windows, around doors, around HVAC and plumbing penetrations, just to name a few. Consider a vapor permeable air barrier for New York City climate. And wrapping up our envelope section, we have the EGC criteria. So implementing these strategic envelope measures can help achieve the critical points needed and mandatory requirements for EGC. True or false? So we have a quiz question now. I didn't speak to it exactly, so we'll see what everybody picked up. True or false, a low R value is one indicator of an effective building envelope. And speaking of building envelope, I do want to point out that you don't have to meet just those minimum requirements for EGC. Going above and beyond and building to a standard like Passive House can really help save energy and provide a more resilient structure over time. So lots of different things to consider when we're talking about a high performance building envelope. But a lot of you are right here. It is not true that a low R value is good. The higher the R value, the higher the insulation. Of course, there are considerations on your particular project with spacing and constraints and diminishing returns. So you want to consider the optimal R value for your particular project. and we will take a 5-minute break. We're at about 10:32. So we'll come back at about 10:37. If anybody has any questions, please feel free to type them in the chat, and we'll see you in a minute. Okay, we are coming back from the break and moving right along. We're going to jump into one of my favorite sections, heating and cooling. So we'll jump right in. Hopefully everybody's back from the bathroom and grabbing their coffee and is ready for heating and cooling. High performance, cold climate, all electric space conditioning systems will reduce our energy use and carbon emissions while providing efficient heating and cooling to occupants. The performance of the mechanical system is contingent on the integrity of the building envelope. So just a shout out back to the last section, smaller capacity and more efficient systems are critical for electrification, particularly to manage demand on the grid during peak times. So we're going to start with a little bit of a heat pump overview. Heat pumps are critical technologies for electrification. They don't generate heat. Instead, they transfer thermal energy from one place to another. Heat pumps in that way can be sort of 2 to 3 times more efficient than the standard combustion equipment. If you think about the standard equipment being 85% efficient, condensing boilers may be 95% efficient, while heat pumps, we say 200 to 300% efficient. In reality, it's more that they're moving heat from one place to another rather than generating all that heat themselves. We'll be reviewing 3 types of air source split heat pumps, referred to as mini split, multi-split, and VRF. We'll also look at the packaged air source heat pumps as well as ground source heat pumps. And there's a lot of different names for a lot of these things. You might have heard something different in the field. We're going to use some consistent nomenclature here just to keep us all on the same page, but feel free to ask any questions in the chat. All right, so heat pump considerations. We have to think about utility billing. In New York City, heat is often paid for by the owner, but the heat pump systems provide heating and cooling. So determining the utility configuration is really, really important early in design. Cold climate technologies. So for New York City's climate, it's extremely important to select cold climate technologies that can operate efficiently in low temperatures. Thermal zoning. Certain systems require proper zoning to ensure efficiency is maximized and the system operates as intended. Outdoor roof space and access to the outdoor equipment needs to be considered. These systems do obviously need to be maintained over time. We also need to think about refrigerant leakage. Installation contractors must perform pressure testing, evacuation procedures, and startup per the manufacturer's requirements, and they must properly document all of those results. We have to think about condensation. All indoor heat pump units require condensate drain lines for cooling, and outdoor units require drainage for defrost in the winter. Maintenance, certain systems require additional maintenance because of more equipment, or they require access to apartments to diagnose issues. So something to consider. Single zone systems that provide heating and cooling to one apartment. That's a mini split. Single zone, 1-to-1, often less than 1.5 tons. As shown in the diagram here, you can see there is one outdoor unit for each indoor unit. That's when we say 1-to-1. The indoor units can either be ducted or ductless, and you can kind of see those 2 options in the photos on the left-hand lower side. Typically, the tenant will pay for heating and cooling, but these units can all be wired to the house meter. It's typically used for buildings less than 7 stories or those with balconies for outdoor units because of the refrigerant line lanes, meaning that the indoor unit has to be close to the outdoor unit. These tend to be lower in cost than VRF due to less equipment, fewer materials, and the ease of startup, and they require less training to install. And there's really a larger contractor base to install and service these systems. They often do in the field have higher COP than VRF systems. We have to consider, though, the maintenance is often a concern with decentralized systems because of the increased quantity of equipment. There's lots of outdoor unit, and an outdoor unit is needed for every indoor unit. So that takes up a lot of space Maybe it can be hung on walls, put on balconies, or use rooftop space, but that will impact, other considerations such as PV, etc. Next, you might consider a multi-zone system, possibly 2 or more indoor units to each outdoor unit. And they can have separate individual zone controls for each indoor zone. As you see in this diagram, multiple indoor units can serve different rooms, different apartments, and can be all connected together. This can be ducted or ductless again, and it's typically tenant paid heating and cooling. But if the heating and cooling needs to be paid by the owner, then that would be wired back to the house meter. The buildings, these are often also used for 7 stories or less, or those with balconies. Again, this is due to that refrigerant line length limit. So the limit between the outdoor unit, limit in length between the outdoor unit and indoor unit. They still tend to be lower cost than VRF because it's less equipment, materials, it's easier to start up, and they require less training to install. Skipping down to the multi-zone, the VRF units. So VRF units are multi-zone. They are often larger systems, and they can provide heating and cooling to one large apartment or often many apartments together. When you have a system called heat recovery, those systems will provide simultaneous heating and cooling, meaning that one apartment could require heating when the next requires cooling. They're more, this kind of heat recovery system is more efficient, you have more control, and it can meet the thermal needs of different apartments at the same time. Unfortunately, this heat recovery system versus what they sometimes call in VRF heat pump system, the unfortunate news is that the thermal zoning needs to be carefully planned in order to actually realize the potential for savings there. And it can add cost to the project and complexity as well. VRF is available with and without heat recovery, but many manufacturers do state that heat recovery models should be used in multifamily buildings. So take that into consideration as you're planning your design. Oftentimes, this will be wired directly to the owner's meter, and there is an opportunity to have the tenant pay for heating and cooling. You'd have to use the manufacturer's billing algorithm, and it can get a little bit more complex since the system is all combined into one. These are typically used for taller buildings because the systems can have longer refrigerant line length limits than mini and multi-split systems that we talked about earlier. You have fewer rooftop units, but multiple dwellings or spaces might be affected if one system goes down. And you also have a lot more complex piping and installation and startup. On the opposite end, we have package terminal heat pumps. So these are unitized. They provide heating and cooling directly to a room. And they typically will be wired to the residence meter unless you plan for it in advance. So you can have it wired to the owner paid heat. This approach is still being considered and developed in the early stages. Really, the package terminal heat pumps are still in pilot phases, and we're doing testing on these types of systems right now. But it's a really interesting opportunity for minimizing the refrigerant in your building. So it's something to definitely consider. Some of these models will provide heat recovery ventilation kits. So the considerations, there's no ductwork. Refrigerant is contained within the units, which minimizes the risk of leaks. It can be a retrofit option in a PTAC building, and it's easy to upgrade for more efficient and lower global warming potential refrigerants in the future if they come out. And so all you would have to do in the future is pop this out and put in the new unit that's low GWP ready. It's really important that you choose cold climate models. I think a lot of us know of the early PTHPs, package terminal heat pumps, that went to electric resistance heating at about 40 degrees. That's not going to work in our climate zone, but that's why these high performance models are really being tested and rolled out today. We also need to make sure that these units have condensate drains at every unit, as we mentioned before. So that can be a challenge in existing projects, but for new construction, it can usually be straightforward. Ground source heat pumps. These are extremely efficient with very high COPs, 3 to 6. Ground source heat pumps work with an underground heat exchange loop, and the heat pump provides heating and cooling to multiple apartments. Typically, the owner pays for heating and cooling. And you can also connect the domestic hot water system as well. It's not suitable for all sites. New York City has a geothermal feasibility mapping tool, which I believe we can link to in the chat. This chart right here, we won't go into in detail because we talked through on each of the slides, but it breaks down our typical heat pump technologies for multifamily applications. And it provides consideration for each system as we talked through. We can provide this chart as a supplemental resource. We'll either provide in the chat or after this course. So no matter what system you choose, but especially for the more complex field installed systems, it's important to ensure that the commissioning agent is incorporated early in design and is involved throughout the construction process and into occupation, because you need to ensure that these systems are designed, installed, and operated as intended. Especially with systems that are newer to the market, we need to consider how they're really going to function and do some testing in the field. But really for old systems as well. The EGC criteria, so like the envelope design strategies before, implementing these strategic heating and cooling measures can help achieve critical criteria under the operating energy category and earn points for achieving greater efficiency over the baseline or certifying under low or zero energy performance building standards like Passive House or Living Building certification. So we'll jump right into ventilation. One of my other favorites. So a balanced energy recovery ventilation. This will improve indoor environmental quality by providing fresh air while reducing emissions and energy use compared to traditional ventilation systems. So ventilation is required in all buildings, but business as usual in New York City has been exhaust-only systems that frankly don't work well or really don't work at all sometimes. Without proper ventilation, a variety of contaminants can build up inside. These include outdoor allergens, pollutants, dust, and moisture. These contaminants can also lead to mold, mildew, rot, and trigger respiratory issues like asthma, and cause structural damage to the building. This type of damage is the leading driver of insurance claims. As building envelopes become tighter, ventilation becomes even more important, particularly for ultra-tight envelopes like Passive House standard. So balanced ventilation, which is exhaust and direct filtered fresh air, is best practice. Balanced ventilation can control moisture and pollution better than an exhaust-only system. We'll focus specifically on energy or heat recovery ventilators. ERVs and HRVs recover waste heat to precondition incoming outdoor air and significantly reduce demands on heating and cooling equipment. This efficiency enables engineers to specify much smaller and economical heating and cooling equipment that is typically required for than what you would typically require for conventional construction projects. Some projects are even able to forego heating and cooling sections on make-a-bare units altogether thanks to the energy recovery system. It's something to pay attention to. HRVs transfer heat only, while ERVs transfer heat and moisture. Keep in mind that these ERVs and HRVs, but really also for any air supply system, you want to select high performance filters such as MERV rated filters. ASHRAE generally recommends MERV 13 or higher to improve air quality of outdoor air, particularly in locations with high PM 2.5 concentrations like near highways. So just because it's outdoor air doesn't mean it's fresh. There are two options. We can look at a centralized system or a decentralized system. So for decentralized, also known as a unitized system, this is going to serve individual apartments with one ERV or HRV per apartment. In-unit ductwork penetrates the exterior walls in this case. Air sealing around those penetrations is going to be critical. Unitized equipment is wired to the tenant meter. We need to change the filters on these systems. As we mentioned before, we need to change these filters regularly, which means that you need to get access to each individual apartment for a unitized system. This can be challenging, and it can also be challenging to locate the intakes and exhausts to avoid the operable windows and other clearances that are required by code. Outdoor air intakes can get very dirty and require regular cleaning, at least twice per year. And in a unitized system, these grills can be hard or maybe even impossible to reach from inside the building and difficult from outside. On the other hand, centralized systems will serve multiple apartments or maybe the entire building, depending on the size. One or more ERV might be located on the roof, and then central ductwork penetrates the ceilings, roof, and floors, where all the air sealing must be performed carefully. Air sealing of the ductwork is also critical in this case, really with all ductwork, but particularly in central systems with a lot of ductwork. Duct leakage will reduce the efficiency of the system and reduce ventilation or exhaust rates from each of the spaces. This can be performed before drywall is installed, or you can also seal at the end, towards the end of the project using an aerosolized sealant like AeroSeal. But make sure the timing of that is right. Testing, adjusting, and balancing by a qualified contractor must be performed to verify that the system is delivering design, exhaust, and supply flow rates. Maintenance, such as filter changes, is limited to the rooftop equipment rather than the apartments. ERVs and HRVs benefit from balance on the supply and exhaust side, so plan to connect roughly equal flow rates in design. Humidity control is also an important aspect of healthy environments, and this is a strong consideration, particularly more recently. The ideal range for relative humidity in indoor spaces is approximately 30 or 40 to 60%. This is the range at which human health and comfort are optimized and pathogens are reduced. So optimizes for both. When indoor air becomes too dry, it can lead to respiratory irritation and increase the risk of virus transmission, which we all know a lot more about these days. Similarly, when the air becomes too humid, it can create conditions for bacteria to thrive and for mold and dust mites to form, which can trigger allergens and negatively impact respiratory health. For higher performance buildings, dehumidification is required. ERVs and HRVs can be used to tackle dehumidification. The MEP engineer must evaluate the humidity potential of the building carefully and determine whether additional controls of the ERV or HRV or supplemental dehumidification may be required. And of course, implementing these strategic ventilation measures can help us comply with all of these Enterprise Green Communities credits. Before we jump into water, I want to take a couple minutes to see what questions folks have. So feel free to type those in the chat. And we also want to hear what are some benefits of using an energy or heat recovery ventilation system. Okay. Couple folks answering. Sleeping on the ventilation. I think we need to increase all of our airflow rates. Excellent. I'm not able to see the results here, but Jenny, if you want to chime in with some of the results, or maybe type them in the chat, and we'll jump into water.
I can jump in with a quick answer that I wasn't allowed to put into the poll as a moderator, but on a passive house tour that a bunch of us did a few years ago, we toured an older building, an enterprise green building, and a passive house building. Only the passive house building had ERVs, and you could tell how much better the entire building smelled. So smell often equates to pollution and toxins, and it was really tangible.
Yeah, that is an amazing anecdote. I think sometimes it's hard to connect the indoor environmental quality and because you can't always see it or feel it exactly, but smell is definitely one of those things. All right. And we have seen lots of, there's a question in the chat about the ERV, HRV used at Cornell Tech, and I don't remember off the top of my head, but I will follow up with folks after this call. So, water opportunities. Improvements to our domestic hot water system will save energy by reducing the energy it takes to heat the water. Reducing water use benefits the city's sewer infrastructure, which we talked about earlier, so very important. It reduces water pollution, and it can reduce energy use and carbon from DHW and pumping. As we mentioned with heating, reducing our reliance on fossil fuels within the building will decrease the long-term carbon emissions. And it's really the only way to eliminate carbon emissions is to get rid of the fossil fuels on site. So we want to consider electric DHW. There are a few different types that we'll talk about today. We have central configuration, which is most applicable for multifamily buildings. We have two potential options for central systems: air-to-water heat pumps with storage tanks, and water-to-water heat pumps served by a ground loop, a ground source loop, or another heat source. We also have packaged heat pump water heaters, which are more applicable generally to 1 to 4 single family homes, or 1 to 4 family homes. And then we have non-heat pump solutions that are available and applicable for specific applications in general. So we'll get into those as well. For central DHW systems, in general, these systems are best suited for large multifamily buildings where individual water heaters would take up too much space in each apartment, drive up electrical capacity requirements, and create a potential maintenance burden. Storage is generally needed to meet the domestic hot water load in the building. So 2 heat pump options are available for central domestic hot water configurations. You could have air-to-water heat pumps. The majority of limiting factors for these air-to-water heat pumps is outdoor space required and the limitations of these types of equipment on the market. We typically want to maintain storage tank temperatures greater than 140 degrees to prevent Legionella growth. This high temperature is most common for models with CO2-based refrigerant, which conveniently is also low global warming potential. But unfortunately, there are limited air-to-water heat pumps with CO2 as the refrigerant available in the US market. Also, the alternative would be a water-to-water heat pump. So these systems they have to be coupled with a ground source heat pump to provide high temperature hot water. Some buildings will couple it right now with an air-to-water heat pump on the roof or other kinds of strategies for producing the heat needed for the domestic hot water. Packaged and unitized systems such as heat pump water heaters are more applicable in a 1 to 4 family home application. There are multiple options and products on the market. The units require adequate clearance in a space and enough heat gain to replace what the heat pump extracts to ensure proper operation. So large banks of multiple heat pump water heaters are highly discouraged. they place a big demand for heat in a relatively small space. This will drop the space temperature, causing freezing issues or poor operations. These units tend to be loud, which makes installation in apartments undesirable. An operating unit behind closed doors was measured to have a noise level of 50 decibels compared to the recommended 35 or less in high performance buildings. I have seen recently some models coming on the market with looking at lower noise. So definitely keep an eye out for new technology there. They're also, they create cold spots when they run, which can create comfort issues if it's not managed properly. These units are not generally recommended for multifamily applications, particularly in New York City because of the dense population, which makes adequate spacing almost impossible. And then non-heat pump solutions. So in certain applications, other electric domestic hot water solutions are better suited. So a point of use water heater, which is electric resistance, is a great solution for a common area bathroom or an office kitchenette. These small electric heaters are installed right near the fixture. Electric resistance heaters are a good solution for specific application like tenant fit out spaces. These solutions reduce the distribution losses that come with a large central system. And since these products are lower efficiency than heat pumps, they do require a relatively large electrical capacity. So they're really recommended in spaces where the usage is low and the losses from recirculation would be too much. So there's also several strategies to improve overall domestic hot water distribution efficiency. So consider your plumbing layouts. Approximately 30% of the energy use associated with domestic hot water is actually wasted in distribution, waiting for the hot water to arrive at the point of use. Efficient piping layouts will reduce this by 40%, or they can reduce it by 40%, that amount of time that it takes for hot water to reach a fixture. Saving both hot water and energy in these systems. You can also lower your upfront material cost as well, because it reduces the overall piping in the building. We can also consider wastewater and drain water heat recovery systems. The drain water heat recovery systems are designed to capture that heat that's lost from the hot water going down the drain to preheat the cold water that enters the water heater. There are off-the-shelf solutions with no moving parts for single-family homes and small buildings, making the application relatively straightforward. But wastewater heat recovery through a packaged unit can be beneficial in larger buildings as well. Additional accessories like a black water tank might be required, though. We also want to consider, particularly for EDC, the water monitoring and leak detection. We first saw leak detection required for projects under the 2015 criteria. It helps teams monitor consumption and be able to respond to leaks and inefficiencies right away. Monitoring water consumption by fixture, dwelling unit, or riser allows a more nuanced understanding and management of water consumption than the typical whole building meter. While there's an upfront cost for the added meter, it reduces the effort and increases the likelihood that you will actually find the leak. However, someone still actually has to pay attention to the meters and the results so that they can address the leaks. Also, of course, low flow water sense fixtures are critical. They're a familiar New York City overlay requirement, and so make sure to specify low flow fixtures and aerators, water sense certified where applicable. If electric domestic hot water is not feasible for your project for whatever reason, there are several preemptive solutions that project teams can consider for future-proof or electric-ready design. Ensure that the domestic hot water distribution and recirculation system is properly sized, efficiently laid out, and balanced. This one is easy because it makes sense now and it makes sense in the future. Install isolation valves around the equipment to make isolation and removal of specific portions of the system easier during retrofit. This also is a good practice. Choose storage tanks instead of instantaneous gas-fired plants. If you don't use tanks now, leave floor space and structural support for them to be installed in the future. As we mentioned earlier, most central electric DHW solutions will need storage capacity. Factor in that extra space to house future piping risers and insulation for chases from the boiler room to the outdoor heat pump unit. Leave outdoor space and structural capacity for heat pump, and leave enough room in your electrical rooms for additional future electrical panels, switching and disconnects. Implementing these strategic DHW measures will help you comply with the EGC criteria. Next, we have lighting and appliances. So efficient lighting yields energy and cost savings while maintaining a comfortable living environment. Electric appliances reduce carbon emissions while improving occupant health and safety. We'll first dig in on lighting. So our reduced lighting power density is reducing the lighting per unit area measured in watts per square foot. Many spaces are actually overlit. The LPD lighting power density, LPD, is higher than needed, leading to wasted energy and potentially occupant discomfort. So optimize your space based on the space type. Use high efficacy lighting and LEDs. Also consider daylighting strategies. Automatic lighting controls can help daylighting in the space, can help make sure that occupants actually capitalize on the daylighting in the space. And consider your window to wall ratio and orientation so that you optimize for the use of natural light in the space. You can be careful in this way to avoid too much glare that will actually cause people to close the shades. Also follow the code requirements for lighting controls and sensors. There are requirements around vacancy sensors, which are manual on, automatic off, instead of occupancy sensors, automatic on, automatic off. So that way, when someone comes into the space, if it's already day lit, then you have to press the button to opt to switch the lights on. We also want to consider electrifying our appliances. This creates a healthier indoor air environment with lower risk of fire from combustion. Gas stoves are a significant contributor to air problems inside residences. Gas leaks, fire, CO poisoning, impacts on respiratory issues, asthma in kids, all linked back to gas stoves. Electric clothes dryers also need to be considered. You can, of course, reduce your energy consumption, but also your carbon emissions and improve your indoor health by considering the electrification of appliances and also reducing your lighting load. And meet these EGC criteria. Now we're going to skip into resilient and renewable systems. Resilient renewable systems reduce carbon emissions and minimize reliance on the utility grid while ensuring the safety of occupants, particularly during extreme weather events. For these types of systems, we are thinking about one, emergency power. Emergency power for critical loads and for common areas. So we want to think about heating, cooling, medication, refrigeration, Wi-Fi charging, efficient. You need to consider efficient generator. You could look at islandable PVs, CHP maybe. For a prolonged power outage, HPD encourages developers to consider resident recreational spaces that can be used as area of refuge with backup power. They might have heating, hot water, and refrigeration available for residents. We want to consider ways that the residents can shelter in place. We also want to consider access to potable water. During power outages, access to water for drinking and sanitation needs is often one of the greatest challenges. During a power failure, residential buildings using electric pumps lose their supply of potable water. There's a lot of different strategies, and in New York City, you can often just rely on street pressure, but you want to make sure that you're balancing this potable water access to a space that is above the floodplain, of course. And then consider access to broadband. This is a newer right of individuals. Using online learning, teleworking, and accessing telehealth and emergency services is critical. So help close the digital divide so we don't, for those who might not have access to tech. For renewables and distributed energy, we want to think about solar PV, solar plus energy storage, or even storage ready for maybe backup power in the future. A PV array needs to be installed where feasible or designed to accommodate a future installation. The building can be designed to accommodate a future installation. Another one of those future-proofing options. We want to focus on PV arrays. HPD has also introduced a solar where feasible mandate. So definitely take a look at that. It requires solar on all HPD financed projects where it's financially feasible. This also links back to Local Law 94 we talked about earlier. Storage can help with backup power solution today. Electric vehicles. Charging may soon be required by New York City law. Currently, there are incentives available through Con Ed, and they can be bi-directional, meaning that the car battery can actually be used to store energy, which can be used in times of emergency. I think we've heard about that throughout the US over the past couple of years. These systems provide emergency power to serve critical loads. So what about one of these systems? Which one of these resilient or another resilient design strategy have you implemented in the past? We'll take your answers in the poll box. And Jenny, thanks for typing the answers to the previous ERV question in the chat. I'm not always able to read and talk at the same time. But if you want to type these answers in the chat as well, that would be great. I can read them off. And we'll wrap up with healthy materials. All right, we got 18 responses. Keep them coming. All right, Jenny, what do we have? To keep us moving, Leanne. Oh, materials. Excellent. Right before we get into materials, some strategies that folks have been using for resilient design. Passive house, that's an excellent one. Folks are using emergency power, EV charging, great. Utilizing the ERV, LED lighting fixtures, just solar. Sad face, I think solar is great. Raising above the floodplain, geothermal design, heat island mitigation. Wow, that's great. I think sounds like folks are really paying attention to the resilient design strategies. So let's jump into materials and see what we can learn there. Careful selection and management of materials can also greatly improve occupant comfort and reduce a building's carbon emissions. And through embodied carbon reduction. It can also minimize impacts to the waste stream. There's a direct connection between material selection and both occupant health, considering the materials or off gases that occupants will come into contact with, as well as carbon emissions. While we focused a lot in this presentation on operational carbon, we also need to consider the embodied carbon, or the greenhouse gas emissions associated with manufacturing, transportation, installation, and maintenance, and the disposal of these building materials. Every single day, we're exposed to potentially toxic content from the materials that make up the built environment. The first step to ensuring the health of occupants is knowing what chemicals we're even being exposed to and what health hazards that are associated with these chemicals. As practitioners and project teams, we are in a position to act on this information and avoid known and potential hazards. We're not doctors, but there are public ingredient disclosures for building materials that allow project teams to make more informed choices for their materials. There are a growing number of sources for ingredient disclosure and understanding potential health impacts to humans and the environment. So a couple of these disclosures, health product declaration, which is a self-declared list of ingredients in building materials by product manufacturer. They report the contents of the building materials, as well as their possible human health impacts and hazards. HPDs, in this case, health product declarations, are overseen by Health Product Declaration Collaborative, a nonprofit organization with members from across the building industry, including architects, designers, owners, manufacturers, and consultants. Another option is declare labels. They are described as a nutrition label for building products, listing its ingredients, as well as key information such as volatile organic compounds, content, and embodied carbon. This was launched and managed by the Living Future Institute. And there are also other third-party verifications, such as ILFI's Red List, UL's Green Guard Gold certification, Cradle to Cradle, which evaluates a product's impact on the environment. Just as transparency regarding the contents and potential toxins within a material, those are key to optimizing selections for occupant health. Transparency regarding a product or material's embodied carbon is also critical to specifying low emissions materials and reducing a building's overall impact on climate change. So you can think about specifying products that have environmental product disclosures, EPDs. These report and provide information regarding a product's impact on the environment, including embodied carbon. You can select low carbon concrete, steel, and insulation products where feasible. Consider these building materials that have relatively low embodied carbon, like mass timber products, such as cross-laminated timber and glulam, which is now permitted under the 2021 building code revision. Select products with low global warming potential where feasible. Traditional refrigerants, as we talked about in the heating and cooling section, typically have high global warming potential, but there are alternatives. Currently, the federal government is in the process of phasing out high global warming potential refrigerants. So keep on the lookout for that. We also want to think about waste management and recycling. Provide additional storage for future waste streams. Enroll the building in DSNY's Zero Waste Building Maintenance Training. Enroll the building staff in a design in DSNY's free e-cycle and e-fashion refashion programs as well. There's lots of programs out there to consider. Material selection is significantly important. Experts such as sustainability consultants can help navigate various informational sources and third-party certifications to help identify materials for healthy and environmentally responsible materials to meet your project goals. Implementing strategic material selection can also help you comply with the material section in EGC. So it's important to read these requirements for all of the criteria carefully, since specific thresholds must be met and documentation must be provided in order to actually earn the additional points. And as a reminder, pursuing all of these particular design strategies does not guarantee certification under the 2020 EGC criteria. So you have to consult the 2020 EGC manual and the New York City overlay and your project team for additional information and guidance. So what new strategy or technology did you learn about today that you will implement in future projects? While people are typing those in the chat, we're also going to give people another 5-minute break, and then we're going to come back for a deep dive into the integrative design process. So feel free to type your answer in the chat and then go on the break. We'll be back in about 5 minutes, starting just before 11:30 to get through the remainder.
All right, welcome back, everyone. Hope you had a good quick break. Thanks so much, Jenny, for typing answers to this question in the chat. Seeing some really awesome responses here. Love seeing advocating for ERVs, passive house principles, efficient domestic hot water systems. This is all really great. I'm really excited to see these and see new construction projects coming down the pike. So now we're going to dive in to our next section. We just learned about these key design strategies and examples of design measures that can make affordable housing projects more climate ready. So now we're going to talk about how project teams can strategically incorporate these measures. And a key to that is the integrative design process. So again, we're going to start with another question here. Just want to ask, what does the integrative design process mean to you? So we'll give you some time again to answer that question. Jenny, you could launch that poll. Looks like folks might still be coming back to their desks, might be settling back in after the break. So for those that are just joining us after the break, we are going to dig into the integrative design process and starting with the question, what does that mean to you? See some answers coming in. And we'll just pause here and give folks a little bit of time to answer this as they come back. Again, for those of us who are still settling back in, we're about to dig into IDP, the integrative design process, and starting off with a quick poll. All right, so Jenny, let's keep this poll up for a little while. I'll go ahead and dive into the content, but let's keep it rolling just for a few more minutes as people are sitting back down. And then once we've had some more folks answer, if you could copy those into the chat as well, that would be great. All right, so integrative design, or IDP, is an approach to building design in which a comprehensive interdisciplinary team collaborates from the earliest stages of design to project completion. So it's really intended to optimize the knowledge of all the stakeholders involved in the project to achieve a well-defined project-specific objectives and while staying within budget and on schedule, most importantly. So conventionally, the design and construction process is pretty siloed. It can lead to miscommunication. There's a lot of back and forth between teams. It slows things down, clogs things up, and costs more in the long run. Whereas in the integrative design process, there's collaboration, critical thinking, and this project team is assembled during early stages and continues throughout the construction. So we're identifying issues as they happen early on. Like Kelly mentioned before in some of our strategies, we don't want to see these issues first thing during construction. So today we'll focus on 6 steps of the IDP process to help us design a climate-ready building. And our first step being assembling the project team. So, as discussed in a conventional approach, many team members, they're siloed, with designers developing their scopes independently with limited input from other folks on the team. Whereas an integrative approach empowers everyone on the team to bring their diverse skills and expertise to the table. Another important aspect of IDP is having a facilitator, a dedicated project manager to coordinate this team and ensure everyone remains engaged during design and through construction. So the PM, the project manager, could be a dedicated role or part of the responsibility of a core team member, such as the architect. So our next step is assessing our climate risk. When we're talking about climate ready buildings, what are these future risks that we're talking about? So Enterprise Green Communities requires the project team to conduct a project priority survey during schematic design, which will guide the project through design and construction. This is a key part of the IDB process in general. But the New York City specific overlay requires that the climate change related risks that we talked about earlier, heat, precipitation, sea level rise, all are addressed using the city's exposure screening tool. So if your project is high risk, then you must use those climate resiliency guidelines that we talked about. The exposure screening tool must be completed during schematic design and submitted as part of the project's pre-build application to HDP and Enterprise. So using those risks and priorities that we identified, we now have to set our project goals. So, using sea level risk as an example, or sea level rise risk as an example, we would then go to our climate resiliency design guidelines to establish measurable goals toward flood protection. So here we're looking at an excerpt from the design guidelines that details how to calculate the design flood elevation, which requires you to adjust for sea level rise in your code required base flood elevation. The design guidelines take you through the process, but we identified the risk, and now we're setting goals, smart, measurable goals, using the design guidelines. We also, want to ask, what are our energy performance and carbon goals? Do we want to set above code performance targets? How are we going to design now to avoid local law 97 fines in the future? So setting these key performance goals at the start with the entire project team on board is essential. We'll also ask, what are our health goals? Our energy performance and climate resilient strategies that we've talked about today have associated health benefits, but do we want to set further health goals, such as earning the EPA Indoor Air Plus or implementing active design strategies? And then what performance standard do we aim for? What's appropriate for the project? So all HPD projects are required to follow the Enterprise Green Communities New York City overlay, as we are all well aware. But this also requires Energy Star multifamily new construction certification. And you can aim for other standards like Green Communities Plus, Passive House, or LEED. HPD projects are encouraged to use all electric passive house standards as they're, the most likely, the best standard to achieve future carbon targets. So next, the project team will work together to, once our goals have been set, we're going to start to develop those design strategies that Kelly took us through in the previous section to meet those resilience, performance, and health goals. So some of the ways the project team will develop these strategies, some of the tools are, one being a design charrette. Design charrettes are great ways to bring the project team together. We used to think we could just have one meeting with the project team at the beginning of the design, get everything on the table, and have it figured out. But we know that it's much more complex than that. Multiple design charrettes are encouraged, throughout the project to make sure we maintain in line with our goals, with our tasks and our budget and design strategies. And I just want to note here, the New York City Accelerator is here to help with this. The HPD overlay provides an automatic point under criteria 1.2 if you work with a New York City Accelerator account manager. Another tool that we're going to use to design is energy modeling. So energy modeling can be used throughout design to compare the performance of different building systems and show compliance with standards. So the type of model or software really depends on the certification being pursued and the design components being investigated. But energy models can go through multiple rounds of revision during the design. Design or spec changes must always be communicated back to the energy modeling team so that building performance projections are accurate throughout and continue to meet certification requirements. Another important tool is underwriting the savings that, the saving goals that we have, our projected energy savings that we're seeing from the models. This allows us to take out a larger loan for the project. So, we encourage you to look at HPD's underwriting worksheets. You can typically underwrite about 50% of efficiency savings and around 75 to 80% of solar savings. And you need to outline everything that should be done in construction during design, before you get there. So include all critical things in your design documents to make sure that they actually happen, such as testing protocols and commissioning requirements. We really need to detail everything so that there's a clear trail, a clear order of operations of what needs to be done when and who's involved, who are going to be the active participants in testing and planning. So once we've set everything up, we've assembled our team, we've assessed our risks, set our goals, and we've designed, we've set our strategies in place, and we're ready to build. So getting back into, documenting everything that needs to happen and during the construction phase. Full-scale mock-ups of elements such as above-grade wall assemblies are really good learning opportunities for the general contractor and tradespeople, especially if we're using new materials or new techniques in the project. These really help teams work out any issues in an isolated scenario before we start installing and replicating throughout the project and have to fix, a bunch of issues. They're really great kind of testing beds. The energy consultant, commissioning provider, architect, and owner will want to review to make sure project requirements are being met and to weigh in with any questions. So they'll need to be a part of the mock-up, review the mock-up, and come back with comments. So these photos here are examples of mistakes that can happen in the field when mock-ups are not provided or are not properly constructed. To meet the air tightness requirements for the passive house standard, an air barrier inspection and testing plan is essential. So this involves a specialist reviewing plan details, scheduling inspections, and developing contractor checklists. These screenshots here are an example of one of the tools that passive house consultants use for large multi-dwelling projects. It's an app for repetitive leakage testing. It can get very repetitive. There's lots to check. So this makes it easy to kind of go through and make sure you're not missing anything, inspecting every element. The app then generates an issue log, which is seen on the right, which can be reviewed and issues can be addressed. So skipping that air barrier continuity plan or the mock-up installation can lead to a lot of issues to pop up during construction. These photos here show some of the mistakes that can occur if issues aren't worked out early, which can lead to long delays and costly fixes. So on the left side, we have, unfortunately, an issue where the air barrier plan didn't include the piping penetration and indicate how to seal around it. So this pipe just wasn't sealed at all. Up here, we see that the energy model did not account for thermal bridging from the metal studs. And down here, looks like the contractor didn't complete the mock-up and didn't properly install the mineral wool. So they didn't cut it to fit snugly. There's these large gaps, which really impacts our envelope. Looks like up here, the carpenter didn't cut the drywall very well around the penetrations, making air sealing pretty difficult to accomplish. And the person doing the air sealing didn't do a particularly good job either way. And finally, at the bottom, it looks like, the drawing showed interior insulation in the wall cavity or on the window, but there was no room to install any. So the window assembly was thermally broken, but the attachments were not. So depending on the certification requirements, installed HVAC systems, and the performance goals that we've established, performance testing, will look different, but it might include duct tightness testing for space conditioning and ventilation ductwork, window tightness testing, compartmentalization blower door testing, or whole building blower door testing. Progress inspections and testing should be strategically conducted throughout construction to make sure the building passes all final performance testing. We don't just want to build it and then test at the end and have a bunch of issues. It needs to happen throughout. So some things to note here. Open communication is critical for testing. Consultants should communicate scope and expectations with the construction team for all inspections and testing, including the key individuals like installers and technicians needed during testing, and specify the locations and systems that they'll need access to. Failures, miscommunications can cause delays. So construction teams should tell consultants if they're not ready and they need more time. We don't want to bring the testing team out if there's no point there. So finally, once we've tested, everything looks good to go, it's time to measure. We need to measure ongoing performance to verify that those design goals we established were met and continue to be met. So some ways to do this are implementing a data collection strategy. This is essential for ongoing monitoring of performance and assess and optimize performance over time. So data can also really help owners understand, when a system is malfunctioning, if there's any billing issues. It's a good way, it's a good practice, for multiple reasons. HPD projects are required to follow the benchmarking protocol, which does require building owners to contract with a pre-qualified benchmarking service provider. And again, Energy Star Portfolio Manager is used for local law 97 and 87 compliance reporting. So it's good to benchmark regardless of the requirement. So no matter how the building is modeled to perform, the actual performance will depend on occupant behavior and building maintenance. Some key strategies to address this are O&M manuals. EGC requires that an O&M plan and manuals are provided for all multifamily projects. So the project's commissioning team should train the O&M team on the specific equipment that they'll have to maintain. This will improve the longevity and efficiency of the building systems, especially if these are new systems. Staff really needs a thorough training on what they're going to have to be maintaining. One thing to note, CUNY's Building Performance Lab does offer a free 30-hour building operator training that can be incorporated into staff requirements. And resident manuals are also really good tools. Residents need to be made aware of the benefits, use, and maintenance of their home's green features. So EGC requires resident manuals that highlight building systems or controls that they will encounter when adjusting settings in their homes. And residents should be encouraged to consider and conserve their individual energy use throughout the year. And EGC requires that these manuals include resiliency information, such as how to locate emergency shelters, cooling centers, hurricane resources, and location of backup power. So with all of these in place, a feedback loop is essential. This really helps identify lessons learned from the design and construction and incorporate those into future projects. The IDP process ensures that these lessons are learned by the full team as well, not just these kind of siloed aspects or individuals of the team, but everyone understands the benefits and the lessons and can bring them to their next project. That's why, the second passive house is always easier than the first one. So again, IDP process aligns with the EGC criteria. It is required as part of it. So we are going to ask another question here. Where do you typically see mistakes happen when you're working on projects? What mistakes have you seen? Where are they happening? Why are they happening? We're looking for anything you want to share here. We'll give you a few minutes to answer.
So while everyone's answering, should I put the exposure screening tool in the chat so people can start to open it up as well?
Yeah, that would be great.
Get into the details here in a minute. Unless
Yeah, this is kind of an open-ended question, so might take a couple minutes to think through it, and feel free to share as much as you want.
all right. And as people wrap up that question and we get them in the chat there, we will, I think, move right ahead to concepts in action, looking at a case study. So Leanne took you through the overview of how that will, how we want to walk through the design process. And we're going to jump in to give you a case study example for beach green dunes. This is a recently completed building. It's in Rockaway, Queens. It's a 2-phase multifamily affordable housing development that was part of a neighborhood rebuild. It was an initiative that started after Superstorm Sandy. We're going to talk about phase 1. It's 7 stories, 101 units, and 109,000 gross square feet. It was completed in 2017. The address is 4419 Rockaway Beach Boulevard in Queens. And we'll also take a look. Where do we see mistakes typically happen was the question. We've got the answers from you in the chat. So hopefully beach green dunes avoided these issues, but we'll see in a few minutes whether they did or not. So ordering materials too quickly without consideration of compliance or climate readiness, that is a good one. Thermal bridging, field conditions, installation, roof layer goes on with no insulation due to lack of coordination. Yeah, we saw some of those photos showing some lack of coordination, air barrier continuity, envelope issues, coordination issues. Yeah, coordination and communication comes up a lot. Lack of testing, installation, waterproofing. These are definitely among some of the issues that we ran into at Beach Green Dunes. So aligning with this first step, assemble. So we'll spend this part breaking down the case study by following the IDP steps laid out that were laid out in part 3 by Leanne. This first step, assembling, is assembling the project team members. So for this particular development, ownership was a key driver in pulling together the comprehensive team with various areas of expertise. So Bluestone had been building passive house buildings for 10 years, initially through the Build It Back program. And so they were familiar with the standard, and they knew from the beginning that they wanted Beach Green Dunes to be passive house certified. Curtis and Ginsberg Architects was brought on board to lead the design. And while they're established and recognized name in the industry, Beach Green Dunes 1 was actually Curtis and Ginsberg's first multifamily passive house project. Bluestone then rounded out the team with a set of experienced consultants, including Johnson & Urban, a mechanical engineering firm with expertise in high-performance multifamily housing projects, and Stephen Winter Associates, a sustainability and energy consulting firm that provided passive house expertise and commissioning services as well. Bluestone's dual role as the developer and the builder helped to streamline the overall construction process. It's not necessary, but it worked well in this case. With the project team assembled, the team could then begin the process of assessing the site's climate risk. So that's why if you scroll up in the chat, I sent the link to the exposure screening tool. That way, everyone can follow along with the exposure screening tool as we go through. This is going to be a critical element of your projects moving forward. So it's really important that you follow along with us and you're able to do this for your particular project. So we're going to do the example, obviously, on Beach Green Dunes, and then you'll be set to go on all your future projects. So this, the copy that I sent is a view-only copy, so you need to save a copy to your computer in order to navigate the document. And we'll ask questions on it, so you'll be tested on your knowledge. And again, answering the questions is required to get the certificate, so please answer the questions in the chat. So if you open the link and you go to the File tab in the upper left, click Save As and download a copy. When you open it up, you should be on the Exposure Screening Tool tab. So first, we're going to look at the heat exposure. The question under the risk screening question, it will ask, does this facility include new construction of the building envelope, HVAC, roof, hardscape, or landscape? For this particular building, we know it's new construction, so yes, we give it a 1. Now we'll skip to the third question. How many annual heat waves are projected? We know this to be a 9 because we went to section 2A of the guidelines based on the project's end of life. The corresponding answer was 9 days. So for your particular project, you would go to that section 2A of the guidelines to find that number of days. For this one, I'll give it to you. Is the facility in a neighborhood tabulation area where with high heat vulnerability? We're going to ask you to find this number. So go to the health data portal. I believe someone will help me link in the chat. And Leanne has some helpful tips in the chat there. So go in and pinpoint the neighborhood. A little hint, it's in Edgemere. So type your answer in the poll. We're going to launch the poll. And type the answer to the heat vulnerability index. Is the facility in a neighborhood with a high heat vulnerability? So what is the heat vulnerability of Beach Green Dunes? Jenny's going to launch that in the chat while everyone works through it. Okay, only 28% participated so far, so we're gonna give you a second to fill in. Hopefully you're following along. Please reach out in the questions if you're not able to gain access to the exposure screening tool. Okay, great. So we did have a very nice bell curve of answers from 1 to 5. People answered each one of those. The correct answer in this case is 3. The next, we're going to look at precipitation. So here in the middle for you, if you scroll down to the next section in your Excel file, but we pasted it here in the middle. Does the facility require new DEP connection proposal or a modification to the existing site plan? In this case, yes, it does. And you would know from your project team for your project. Does this site have a history of flooding during precipitation events? If you look at 311 requests and institutional knowledge, you'd find out, yes, this particular site does have a history of flooding. Will there be a net increase in impervious area on the site as a result of this project? For this particular project, it was yes. And then finally, we'll look at sea level risks. What is the current flood risk? Again, we're going to ask you to use the city's flood hazard mapper to find this answer. So if you go to the link, and Leanne's already put that in the chat, you'll first have to agree to the terms and conditions. You can navigate to the map by changing the map layers in the top right-hand corner. It looks like 3 stacked squares. And make sure the flood insurance rate maps for 2015 are selected. And then search for our site in the address bar. And again, that's 4419 Rockaway Beach Boulevard, Queens, New York, 11691, which is also in the chat. So, is there a current flood risk for Beach Green Dunes? I feel like it's like drum roll, please. We got different answers coming in. Some people changing their minds. I'll give you 2 more minutes. And 90% of you had the correct answer, yes. Yes, there is a flood risk for beach green dunes. So what is the future flood risk? Using the same map, you can select the future floodplain layer. And note that Jen typed this in the chat, that we're not just looking at the current floodplain, but we also have to consider the future floodplain. So if you add that layer that corresponds to the project's end of useful life, then we know that the site is at risk for future flooding as well. Does this site have a, does this site have a history of flooding from high tide events, from local knowledge again, and 311 requests? We know that it does. And finally, are there critical access roads to that site that will be inundated by future high tides? Again, this is a yes. So we're looking at that sea level rise category now. So let's review the answers. First, for increasing heat, the project team answered for the site, resulting in a score of 8, which is a medium exposure rating. Next, for precipitation, the project team answered for this site, resulting in a score of 4, which is a high exposure rating for rainfall. Finally, for sea level rise, the project team answered for this site, resulting in a score of 5, which is a high exposure for sea level rise. So in this case, the climate resiliency design guidelines are critical. The next step in the process was setting the goals for resiliency and performance based on these climate risks and more considerations as well. As I mentioned, spearheaded by Bluestone, the team knew that the project was going to pursue passive house certification. The team established that the building should have an enhanced level of survivability in the event of a future catastrophic storm, such as Superstorm Sandy. That's a key benefit of passive house due to the high thermal mass and robust envelope assemblies. It also addresses the site's medium risk for heat exposure. Due to the project's high risk of sea level rise exposure, the building was elevated to address sea level rise. And to address the site's risk for rainfall and stormwater flooding, several stormwater features were explored, including vegetative and site retention strategies. Ownership also wanted an environmentally friendly building with a relatively small carbon footprint that also had relatively low operating costs. So they went above and beyond while also saving money. They chose an efficient all-electric heating and cooling system, and in this case, VRF. By assessing the risks and identifying the goals, the comprehensive project team was then able to make informed and strategic design decisions. So we'll get into the specific design elements that we used at Beach Green Dunes. It's worth noting that Beach Green Dunes was part of a resiliency pilot through the mayor's office, so design strategies were identified early. Some of the things that we spoke about earlier, so flood proofing and stormwater management were key concerns based on the project's location near the coast. The site is composed of 67% pervious asphalt, 4% impervious concrete, and 29% landscape. They have bioswales with hydric habitat plants to retain the stormwater, and parking areas that are composed of permeable paving. All apartments, mechanical systems, and points of egress were elevated above the floodplain, above the flood elevation. The habitable floor height was 4.5 feet above the base flood elevation. The climate resiliency design guidelines require it to be at least 4 feet above base flood elevation. So we can see that they went above this requirement. The entrance area contained flood vents, which is something known as a wet flood proofing strategy that allows water to flow through even in an enclosed space. And critical equipment was located on the roof. They addressed heat exposure risk by using white reflective roofing and terrace paving materials. The solar array, which we'll get into later, also does double duty of providing shade, like we spoke about. Some of the insights, the combination of these measures selected and installed were able to achieve full stormwater retention on site. But they also help to serve surrounding areas by not adding to flows in the central sanitary and storm systems. For envelope, the design was primarily driven by the passive house thermal and air tightness requirements. The project team chose insulated concrete forms for the assembly since it tends to be tighter than other assemblies like block and plank. Poured concrete provides the integral air barrier sandwiched between two layers of insulation. With ICF, it's important to review all joints and transitions and any penetrations and make sure everything is thoroughly sealed. Envelope assembly performance was designed well above code. So we spoke to R value before. The slab R value is R30, floor over crawl space. The roof was R33 using polyiso, and the ICF walls were R32. They also use high performance windows with a window to wall ratio of only 22% and a U value of 0.22, double pane windows with glass fiber reinforced UPVC frame. The solar heat gain coefficient was 0.36. The whole building airtightness was inspected along the way and then verified at the end through blower door testing. And that's a critical element, inspecting along the way, not just waiting till the test at the end. Some of the insights, Bluestone had experience building with ICF on previous projects, which helped with the learning curve that project teams usually face. While ICF seems very straightforward, you can often have challenges when you're using it in the beginning. Any construction team using something for the first time can be challenging. The windows, since the wall assembly was so robust with ICF, the project team could opt for double pane windows, and that reduced the cost and the embodied carbon from those windows. The noise from the subway was reduced with these high performance windows. So again, you don't need to be triple pane to be high performance windows. The passive house design provided for passive resiliency. The temperature stays comfortable throughout the entire year due to the thermal mass. And in the events of power outages, the building will stay relatively comfortable, though there is also emergency power on site as well. The project team opted for the central VRF and used heat recovery for simultaneous heating and cooling in the apartments. The system is efficient and all electric. And the robust envelope meant that smaller heating and cooling equipment could be installed to meet smaller heating and cooling loads. The savings from reduced heating and cooling equipment sizes meant that funds could be spent elsewhere. Some of the insights from this was that these new technologies for tenants who might be used to heating strategies like oversized radiators and window ACs. So that resident training component that Leanne spoke to, super critical. You need to educate residents about how the new space conditioning equipment will look, sound, operate, even if it sounds like nothing. Projects incorporated unitized ERVs. They efficiently provided filtered fresh air. When these are coupled with compartmentalization, you can really have that balanced ventilation by the ERVs reducing air infiltration between apartments or from corridors. This helped decrease tenant complaints as well. Some of the insights we learned from this ventilation installation. These are new technologies for tenants. They might be used to exhaust fans or operable windows in their kitchens or bathrooms and no direct fresh air. So again, tenants need to be educated. How do the ERVs look, sound, operate, especially if the system is unitized and the equipment is within their apartment? Will the clarity of the system, that it's important to clarify that the system should not be turned off. It seems straightforward, but the ERV is removing stale air and providing them with fresh air and is managing moisture. So they need to understand the implications if they turn something off. The maintenance staff have to arrange access into the apartments to change the filters, as we talked about. An opportunity, this could be an opportunity to conduct an overall check on the systems and the tenants. Some buildings have really wanted this opportunity to check in on tenants, depending on the makeup of the building. You can make it part of a full routine maintenance plan to ensure that things are in order. You also want to look at the outdoor intakes. They have to be cleaned very regularly to address buildup that could block the intake. So access to these points is critical. For the water, a gas boiler was used with cogeneration that provides building DHW. Low flow fixtures with leak monitoring comply with EGC requirements and reduce water consumption and detect water leak issues to be addressed quickly. They also use that high performance plumbing layout to reduce water and energy consumption. Traditionally, DHW uses a 3-pipe model with 1 supply and 1 return and 1 cold water riser. If you use a box model, you can reduce the domestic hot water piping by up to 40%. Reducing your piping length means reduced heating losses, less energy to heat up domestic hot water. Reduced piping length means reduced material. So all of those are important. And of course, you'll notice at the beginning that I did mention a gas boiler, a natural gas boiler. At this time, there was not as much opportunity for electric domestic hot water, but that's something that we want new teams to be considering along the way as these technologies are really developing now. They had electric cooking equipment, which is a passive house requirement. LEDs were installed throughout the building, incorporated windows in the corridors and stairs for additional daylighting. Some of the insights, occupant health improved by eliminating the combustion from tenant spaces. And it eliminated this potential fire hazard as well. This project also, as we mentioned, had the rooftop solar array, which provides renewable on-site electricity production for supplemental power and emergency power. Cogen plant to produce electricity in all of the building's hot water needs, and it can be used as an emergency backup generator. And it supplies for many of the life safety systems in the building in the event of a power outage. They didn't need a backup generator, but they wanted to add something for a resiliency measure. For materials, there was they looked at durability against potential water damage as the prime factor because of that, the risks we talked about earlier. They selected hard, non-absorptive materials with ease of cleaning and drying. Cement board, often installed in only wet areas like tubs or shower enclosures, they were installed at the lower floor to mitigate mold in the event of flooding. Going on to build. After the design strategies were chosen and construction documents are finalized, then we get into construction. So the contractor trainings and mock-ups were critical. The project team was familiar with passive house construction and performance testing and had used ICF in previous projects. They used these lessons learned in developing the air barrier continuity plan and developed project-specific inspection checklists so that the GC and all of the subs were aware of key timelines. They also performed mock-ups to walk through tricky details and material sequencing and set expectations across the board. Progress inspections and performance testing were performed by SWAB at regular intervals throughout construction to ensure proper and consistent installation. Inspecting along the way is critical to ensure issues that arise are identified and addressed in a timely manner. Before performance testing. My cough is to signify how important it is to do that in advance of performance testing. It's important to resolve these issues early, because if you wait until performance testing, it's going to be very costly and time consuming. Stephen Winter Associates performed duct tightness testing on in-unit HVAC ductwork, ERV and VRF, and verified after the ERVs were operational to confirm the airflow rates met the design requirements. SWAP performed functional performance testing of mechanical MEP systems and performed whole building blower door testing to verify airtight construction. And then, of course, at the end, we have to measure, see if it really worked. So the performance, the site energy use intensity was 34.2 kBTU per square foot. If you look at the site energy use intensity, including renewables, that is 29.3 kBTU per square foot. The building will meet Local Law 97 2030 requirements for GHG reduction. The cost of the project's actual annual utility costs are less than half of the baseline conventional building. When you add on the savings from on-site solar generation, the site's utility costs are a third of that of a conventional building. The resiliency results, it provides passive survivability, meaning that it maintains a habitable condition in the event of a power loss. When there was flooding throughout the entire neighborhood, the project stayed bone dry, according to the residents and the building occupants. Awards and recognition are important as well. So once it was completed, it earned the FIAS Plus certification in 2018, and it was certified under Energy Star and Enterprise Green Communities, and earned a first place award for sustainable building as part of the Queen's Chamber of Commerce 2018 Annual Building Awards. So that's exciting. The final steps, of course, are to share the information with the industry and to take all of these lessons learned into your next project. For resiliency, Mark from Curtis and Ginsburg mentions in this quote, the project team was constructing Beach Green Dunes 2, and they were informed of issues with flooding in the lobby of Beach Green Dunes 1. And so they actually were able to then raise the lobby of Beach Green Dunes 2 by 1 foot during construction to provide more resiliency during minor flooding events, which can happen pretty regularly. So they were able to even improve on the first project. And for high performance, Crystal from Curtis and Ginsburg mentioned that they provided more general guidance for project teams. She said, since the completion of Beach Green Dunes, they have gone on to complete 3 other passive house projects, 2 in construction and 1 more in design at the time of this quote. And Bluestone also continues to use passive house as the basis of design for all of their projects, including those currently in design and construction. I'll pass it back to Leanne to drive us home.
Great. Thank you, Kelly. And we just have a few more minutes here. So to conclude, we've covered a lot of content in this training. We just want to highlight some of these key takeaways. The main one being a climate-ready building is merging high performance and resilient design. We really want to reiterate the importance of planning for resiliency here. So one thing to mention, we've kind of mentioned them throughout the training, but there are so many different, resources available to support the concepts and strategies that we discussed. So we want to spend a few minutes talking specifically about the New York City Accelerator. So I'm going to pass it over to Mike Berry to tell you more about the accelerator.
Yes, hi, thank you. You can hear me?
Yep.
So thank you. This was a great training. I haven't had a chance to be part of it yet, so I learned a lot. So just wanted to talk about what the accelerator is. So the New York City Accelerator provides technical assistance for building upgrades. A lot of the upgrades that were covered during today's presentation. I primarily work with new buildings, but we do assist buildings that are going through that have pulled permits for Alt 1s, for doing substantial gut rehabs. What we try to do is we try to provide technical advice, working directly with developers, architects, engineers to figure out what type of assistance they're requiring around local laws, also to make sure that they understand what the local law impacts are, which was covered very thoroughly during today's presentation. We want to try to build the market, not be the market. We want to connect buildings with service providers. These service providers helping buildings to achieve their low carbon or no carbon goals. We offer, which I think is very beneficial to the market, we offer no cost online training. So if you go to the Accelerator webpage and you go to our training site, you will see all the trainings that are currently available. And again, most of these are no cost. There are some trainings with some of our training partners, that there is a cost associated with, but is a good central clearinghouse of all the trainings that we feel like would be beneficial for the market in New York City. And lastly, we really work and try to find ways to help, especially in new construction, find financing options and incentive programs to help offset the cost, the incremental costs of meeting the codes in New York City, and future-proofing buildings for future local law fines. So again, our program, the New York City Accelerator, is here to assist, provide technical assistance and advise projects, but also to provide training and financial support. We can go to the next slide. Oh, thanks. So how does the New York City Accelerator work? So who's eligible for the program right now in New York City is any building over 5,000 square feet. And this is for new or existing buildings. We're looking for buildings that we can make a substantial impact on. So for new buildings, we're looking for buildings that are in schematic design, early in construction phase. We do have ways to assist smaller buildings by referring to some of our partner organizations, but primarily we're looking for those buildings 5,000 square feet or more that we can provide technical assistance for. The way it works is you call us or you can email us. We'll be providing some contact information on the next slide, and your projects get assigned to a dedicated account manager. That account manager is going to follow the project, identify all the key areas that are needed, and all the resources that are needed for your project. Once we provide that information, we're involved through the whole process. We're not just going to provide this information and then cut you loose. We're here for the whole project process. So from beginning to end, an account manager can assist on your project. The best part of all, and there's no catch here, is the project the program's absolutely free to participate. There's no cost, there's no sign up, there's no commitment. We hear a lot from participants that are concerned that getting involved with the accelerator is going to add more costs. It's going to create more time on their project. It's just the opposite. We're here to assist. It's free, and please feel free to reach out to us. And with that, this is our contact information. Again, feel free to reach out to us with any projects, any project questions you may have, or if you're interested in taking a training, we're here to assist.
Great, thank you so much for that. And just want to plug again, don't forget that engaging with the accelerator does earn you an additional EGC project point through the New York City overlay. So some other resources. This presentation was put together in partnership with BEX. BEX Ed is another kind of central hub of trainings and information on high performance and resilient buildings. We've also linked to some resources. We will share these as well. Following the presentation, we're going to be sharing out a lot of useful links and information, and make sure you have access to everything that we talked about today. So just to go back for next steps, you will receive a certification of completion for attending this training by HPD. So be sure to coordinate with your project team, including any consultants managing a project's pre or post build submission to HPD or enterprise, in case you need to provide documentation confirming that you've attended this training. You should receive those certificates within, about a week or two. We are right at time, so we don't have time for additional questions. If you didn't get all your questions added to the Q&A, feel free to reach out to us. We'll follow up with an FAQ of the questions that were asked. These are great questions and useful feedback, so we'll make sure you have access to those following the presentation. And again, just want to say thank you to key advisors and contributors to this training, including the accelerator and Curtis and Ginsberg Architects for sharing information about the Beach Green Dunes case study. And thanks so much for spending your morning with us. It's a a long time, but we appreciate your participation, and good luck. We look forward to hearing and seeing projects to come. Jen, if there's anything else you want to share, feel free. If not, we'll see you folks later.
Just a thanks to you guys and a thanks to everyone who joined. Stay tuned for news on May 1st around some exciting program or programs that we're launching and design guideline updates for new construction this summer.
Great. Thank you. Have a good day, everyone.